right, so our first presentation this afternoon is going to be by Trent Thomas with CDM Smith. It's called Repair of a Reclaimed Coal Mine Site Damaged by the Historic 2022 Yellowstone Area Flood Event. Trent graduated from Montana Tech with a Bachelor in Science and General Engineering in May 2014. He's been employed by CDM Smith since graduation and holds a Montana Professional Engineer's license. He also holds a certification as a project management professional through the Project Management Institute. During his consulting career with CDM Smith, he's been involved in a variety of mining-related projects, including projects to support active mine operations for industrial clients and legacy mine cleanup projects for government clients. So join me in welcoming Trent.
Yeah, that should be good. Okay. Yeah, I'm Trent Thomas. I am a civil engineer and project manager with CDM Smith out of the Helena, Montana office. Today I'm going to be presenting on a project that CDM Smith did in collaboration with Montana DEQ, that is repair of a reclaimed coal mine site damaged by flooding. So this project occurred at the East Bench Mine, which is a historic coal mine located just on the outskirts of Red Lodge, Montana, that was in operation from 1887 to 1932. After closure, there was a significant amount of coal slack material left at the site, some open portals, and in subsequent years, there were some seeps discovered on site, as well as some subsidences. In the 1980s and 1990s, the Montana Abandoned Minelands Program performed a series of reclamation projects at the site. Those included closing a couple of portals, filling in subsidences, constructing channels and ditches to drain portal flow, as well as seeps that were present at the site. And finally, they constructed a coal slack repository on a low terrace, which was adjacent to Rock Creek, just outside of Red Lodge. In June 2022, the greater Yellowstone region experienced a significant flood event that impacted this site and damaged the coal repository, which you'll see here in a couple of slides. Subsequent to that event, Montana DEQ issued CDM Smith a task order to assist with design of engineered design for reclamation of the coal repository, as well as construction oversight and management activities for the project. So a little bit more about the flood. It occurred in mid-June 2022, and it was the result of heavy precipitation combined with high temperatures and significant snowpack in the higher elevations of the region. This resulted in a rain on snow flood event that was later categorized as an approximately 500-year level storm event. The USGS stream gauge near Red Lodge, Montana had a peak discharge flow of 5,520 cubic feet per second. And for a little bit of context, I looked this morning, and in June 2024, the peak discharge for the for spring runoff for that year was 1,460 cubic feet per second. So it was roughly 5x a typical spring runoff event. To provide just a little bit more context, I've got a couple of videos here that kind of show the level of flooding that was occurring in the region. Is there a way to get that on there? Do one of those for now. Okay. Okay. And this wasn't Rock Creek. This was a different stream in Yellowstone National Park. But this is just to give a little bit of context of the level of devastating flow that was seen by this event kind of throughout the region. So we'll pause that. And then I just have one more here that shows our actual site conditions during the flood. I lost my mouse. There we go. And so this is actually the repository itself here. You can see the flow water eroded approximately a third of the repository. The floodwaters are right up along the toe. It wiped out a bridge just upstream of the site here. Now I'll get it back to this. Okay. So as you can imagine from those videos, the local communities, including Red Lodge, experienced significant damage. There was damage to bridges, road, homes, some of which were completely destroyed or washed away by the flood event. In addition to that, a significant amount of stream bank was lost in this event, and there was a lot of channel migration. In addition to significant alluvium deposits of cobbles and rocks from the flood. At this particular site, as you can see, the damage to the repository itself, a significant portion of the repository was actually washed away by the flood, resulting in a dangerous high wall that was left post-flood. And the purpose for this project was to restore this and mitigate the potential for future erosion at the site and transport of coal material offsite from Rock Creek. So the reclamation effort was three-pronged. We had a hydrologic and hydraulic study and engineering design in phase one. Secondly, we had initial temporary stabilization that was performed at the site. And then finally, we had construction for final reclamation of the repository. So for the H&H study and engineering design, the first step was to develop an existing conditions model. That was performed by using post-flood LiDAR to develop topography for the site, to develop an existing conditions model. As you can see here, this blue outline here, this dashed line, that's actually the pre-flood channel. And so all this material was washed away and the channel significantly migrated from its pre-flood banks. So overlaying on this, at the same time that we were doing the existing condition model, we were developing an engineering design to reconstruct the repository and stream bank. And so this is just an overlay on this aerial image here that shows the extent of material washed away. And then we used the proposed conditions for the reconstructed repository to develop a proposed condition hydraulic model to help establish the design criteria for the reclamation. That included using that condition or proposed condition model to develop flow velocities and shear stresses to size riprap for stream bank reconstruction at the site. Getting into the engineering design for the site, the primary criteria were to eliminate placement of coal within the floodplain and below the modeled 500-year flood water elevation, create a stable slope, cap that slope to promote vegetative growth, and reconstruct the stream bank. So to do that, and another design criteria was to maximize the reuse of on-site material to minimize the need for import material for construction. So to do that, the design included borrowing coal material from the, the portion of the repository that wasn't eroded back here, using that material to grade out the high wall and create a stable 2.5 to 1 slope angle on site. Um, Additionally, select fill was imported. Select fill and alluvial cobbles from on site were used to bring up the base elevation below the repository to get us slightly above that modeled 500-year elevation. Uh, so to keep the coal above that elevation. Um, and then the design also included reconstruction of the stream bank. We went with a soft armored bank, so riprap was designed here to withstand the velocities from the model, and then that was actually designed to be capped with growth media and planted, and also incorporate willows to provide some vegetation on that embankment. Um, and then to cap the coal slack material, the design included using 5 foot thick layer of select fill on the exterior of that coal material on the slope, with a 1 foot cap of growth media on top of that to facilitate revegetation. So phase one was temporary stabilization of the site. That was performed in the spring of 2023. And essentially the purpose of that was to stabilize the site and prevent further erosion during the spring runoff of that year. And so temporary stabilization measures that were performed out of the site was to construct a wall out of eco blocks along the edge of the stream channel, and also use on-site alluviums and cobble to build a berm. That was designed to withstand the spring flow events and keep water away from the high wall and eroding additional material from that site. Here's some photos of the temporary stabilization. Along here, the eco blocks that were used to construct that wall, in addition to the materials that were used to construct the berm that's between the channel and the high wall there. You can also see here there was a lot of debris, and there was miscellaneous trees, other rubble that was in there. And so we got in there and cleaned that out prior to installing this temporary berm. The final reclamation construction was performed in the fall of 2023. Olympus was the contractor that performed the on-site work, and CDM Smith performed construction oversight during that time. To reconstruct the slope, we designed it, or we had compaction specifications that required that coal material to be placed in 8-inch maximum lifts and being compacted to 98% max dry capacity or max dry density. The stream bank was reconstructed with riprap and was later capped with growth media material. There was also a ditch that had previously flowed across this location that had to be reconstructed as well. And so a riprap ditch with some geomembrane fabric was designed to convey that flow. So here's some photos of the phase 2 construction. Here you can see the cobbles and alluviums that were deposited during the flood that was used initially to build a base to work from. And heavy machinery was used to remove the high wall and begin the slope construction. In this bottom left photo here, This is the select fill being placed to also build up that base to get us to that modeled 500-year flood elevation to keep that coal material above that level. That material was compacted with rollers and was also moisture conditioned during construction to achieve that compaction specification. And over here on the right, this is the actual coal material being placed. This is a lift that was placed and being rolled for compaction there. On the outside, you can see that lighter brown material. That's the select fill that's being used. And essentially during construction, we started at the bottom, started building lifts up with the coal, and then simultaneously building up the select fill on the outside for the cap. So we were working our way from the bottom up. During the construction, we did encounter a couple of challenges. The biggest ones were with our coal compaction testing. Like I said, we had a pretty rigorous specification of 98% max dry density compaction. And because of the organic crystalline structure of that coal material, it held a lot of moisture. And so we weren't actually able to perform field nuclear moisture density tests without making lab corrections. And so we would have anywhere from a day to a 2-day lag time from when they took the test in the field to when we actually got the results. And so as you can imagine, if you're building a 20-foot slope up in 8-inch lifts, that could result in a pretty significant delay to your contractor if you're having to wait a day or two after every lift to say we're good and to keep going. So what we ended up doing is after we established a method that was working at the site and we had the data to back up that we were meeting compaction, we actually implemented a method spec and used that, and we're allowed to keep the contractor on schedule. While we were using that method spec, we still did do the nuclear densometer testing, and we would verify those results. Sometimes it was a day or two later, but we were meeting our compaction every time, and that method spec allowed the project to stay on schedule. The second big challenge that we encountered during this project was the design assumed that when the repository was initially constructed, that all that coal material was compacted when it was placed. But what we saw during construction is we were seeing a 50% reduction in volume as we compacted that coal material. So we ended up having to revise the design a little bit to generate more material. And so the final constructed slope actually ended up being a couple of feet lower in elevation than the design called for, just because we had to generate that additional material from the top of the repository to maintain that stable 2-to-1 slope angle out there. Here's a couple more photos of that final reclamation. This lighter material here, that is the select fill that was placed in that 5-foot lift to cap the coal slack material. This darker material, that's the growth media topsoil that was being spread. In this photo, you can see here that stream bank was reconstructed with riprap, but in the photo on the right, that was actually covered with growth media as well. To facilitate vegetated growth and have a growth medium for those willows to take hold in. Down here in the bottom left, this was the channel that was constructed. You can see here, this is the original channel, and right up to this level here, this line, that's what was eroded by the flood. So we basically had to reconstruct an extension of that channel. And then this is the site in August of 2024 that shows the successful revegetation of the site. Basically, the whole thing took really well. We got veg coverage on the entire repository, including the stream embankment as well. You can't see them in here, but there were willows that did take and started to leaf out. So yeah, overall it was a successful revegetation effort out at the site. And finally, I think this site underscores the need to consider climate resilient reclamation projects, um, both in design of new projects. I know typically a lot of projects are designed with like 100-year flood event in mind. Um, but being is that it seems that we're seeing more extreme flood events more frequently, it may be worth considering, designing to a higher level, like a 500-year event, and, looking at, is there a cost benefit to spending a little bit more money up front to beef up your design versus having to go back and reclaim something that ends up being damaged for a flood. Um, the other thing worth considering is, doing an inventory or evaluation of previously reclaimed areas and looking for any potential vulnerabilities or risks that may be associated with those sites from these larger events. And if there are ways that those can be mitigated before the event happens. And as far as acknowledgements, I'd like to acknowledge Bob Flesher and John Babcock. They were the DEQ project managers that we worked with for this site. Olympus Technical Services, they were the construction contractor that did a great job on the project. And then Colin Scheel was our CDM Smith field engineer that spent a couple of months down in Red Lodge performing oversight duties during this project. So. Other than that, any questions?
Was the 2022 event, was that a 500-year flood event, or if not, what was it?
Yes, to my understanding, that's what it was categorized as. It's a 500-year event.
How was the dynamic of working with the homeowners that were near where the river ended up being?
They were actually pretty good to work with. The whole town obviously had experienced significant damage in various ways. So for the most part, they were great to work with. We had to work with Northwestern Energy as well. They had some infrastructure there. But all in all, everyone was great to work with and collaborated, and we didn't have any issues with landowners or other stakeholders out there.
Two questions.
Oh.
How much contaminated material was lost to the flood, or how much repository material? And then was it considered reciting that repository further away from the river?
So I don't have a volume or a number for the amount of coal slack that was eroded during the flood, but as you can see from those photos, it was probably a third of the material that was in the repository. As far as reciting, that was originally discussed, but ultimately it was determined that if we could design it and keep that material above that modeled 500-year flood elevation and also beef up that stream bank to mitigate the potential for erosion in the future, that would be a effective remedy.
I have a quick question. I was curious, were you familiar with the hydrologic analysis? Did you do that part? Can you speak to any of that part? I was just curious.
I did not do that.
Okay.
I've done like a very basic H&H analysis for other clients. But no, we have someone else did it that's very good at it.
Okay. I was just we do a lot of floodplain mapping, and I know that was in the process of being remapped, and then the flood hit and new hydrology had to come out to incorporate that flood. And so I was curious if you knew which hydrology was being used and if it incorporated that new flood data, because I know it kind of changed the hydrology drastically. So
Yeah, I don't know the answer to that. I know that we did coordinate with the local floodplain administrator, and I know that FEMA was involved with that, redoing the flood mapping.
Perfect. Cool.
Yep.
I was curious. Thanks.
Thank you.